Alrighty, so multiplying and dividing rational expressions. This is very, very similar to the last lesson on simplifying rational expressions. So if you haven't watched that video yet, or you're not the most comfortable on factoring, go ahead and go back to that simplifying worksheet and video. And we are going to have now 4 different things, 4 different terms that we need to factor. So we are going to be factoring 2 different numerators, or 2 tops of the fraction, and 2 bottoms, but some of them are going to be already factored, or like this example, they're just going to have 1 number. So once again, we're using either GCF or Big X, depending on what the problem looks like. And we'll just dive right in with some examples. So what I like to do for mine is I draw a little chart looking thing, and it usually takes up the whole paper for me. And then I like to write my final answer just like off in the corner up here or on a Post-it. So if you need more paper, feel free to use scrap paper, that's just fine. So when we look at this first one, we see that we have 3 terms. So most likely it's going to be Big X, and there's no number living in the front, so we don't have a greatest common factor. So this first one, we can go right to Big X. If you don't use Big X, no big deal. You can just find the numbers that multiply to 5 and add a 6 on your own without the help of the Big X. But if you're using it, we'll put the 5 on the top and the 6 on the bottom. If we take our calculator, honestly, you probably don't even need your calculator for that one. If you do 5 divided by 1, you get 5. And those are the only numbers that go into 5. So you know it has to be 1 and 5, or 5 and 1. And you need them to add to a positive 6, so you know that they both have to be positive. And they also multiply to a positive 5. So that's why they're both positive. You can rewrite the problem here if that helps you. I know a lot of students like to rewrite the first top left problem. That makes life a little easier for them before going to their answer. So we're going to factor all 4 parts, and then we're going to get to cross some stuff out today, which is the fun part. So we have our m plus 1 and our m plus 5. Doesn't matter the order those go in. And we're going to do that same thing for all 4 parts, and it's a lot of factoring. So if you like factoring, you're probably going to love this. If factoring is a little tricky for you, just take it step by step. Ask yourself, am I doing GCF or Big X? If it's only got 2 terms, you're going to do the GCF because there's only 2 of them. And also it has numbers in front of it. So we're going to look for what number goes into both 10 and 70. Since they both end in 0, we can do a 10. And we always want to try the smaller number of the 2 when we're doing GCF, and then work your way down. So if like 10 didn't work, we could try 5, etc. And then we got, both of them got m, so we're going to divide them both by m as well. So we will take our 10m as our GCF. I really don't want to forget that. So I'm going to put that outside of my parenthesis. And then I got 10 divided by 10, which kind of cancels each other out. You could put it invisible 1. But since you also have m squared over m, that means you have an extra m on top. You don't really have to put the 1. And then we have negative 70 divided by 10. So that is negative 7, and the m's cancel. So these ones take a little bit of time, but we'll probably just do a few and see how you guys feel on it. Good news is this one's done. This bottom right denominator, that one's done. So it's kind of nice. And when you're looking at starting to cancel stuff out, I like to caution people, it has to be in the numerator and the denominator. So if you have like a repeater in the numerator, I mean, neither of these repeat, but if they did, we can't cancel them out. It has to be in the denominator. So if we looked at this one over here, the greatest common factor again is 10. And it's also an M. I thought for a second that was a 10, but it's 70. So can't do much with that yet. So if we divide these both by 10M, because we both have an M, we want to put that out front so we don't forget about it. If these cancel, we can put a 1 as a placeholder, but since there's more baggage in that particular problem, we can just go, okay, 2, take away the invisible 1 is just a singular M. But if everything cancels over here, that's where you got to put 1 as a placeholder, which some people try to put a 0, but bust out that calculator. 10 divided by 10 is not 0, it's 1. And then you can look through and see if anything cancels. Then we're done. So we look through, we see anything speak to anybody that looks like it could cancel out between the top and the bottom.
How about 10M?
Yeah, good. So those greatest common factors are the same, so they can go bye-bye. They can definitely be across from each other, and they can be top and bottom as well, as long as they're not on the same level of the fraction.
And you've got M plus 1?
Mhm. Perfect, good. Kind of looks like a little messy at the end. So what I like to tell people is, if you leave this on your paper, I'm going to be able to figure it out. But I mean, mine's written pretty neatly for the most part. If you would like to write this as one concrete answer, you're going to take your leftovers that are on the top of the fraction, either of the numerators. So for your final answer, you'll take those, bringing in the numerator denominator words into algebra, but you can just think top of the fraction, you're going to put those together. You don't have to like FOIL or anything like that. You can just leave it in its factored form, and then that little 3 is left over. Yeah, I don't think I missed anything, because that one, and that one. It's a lot of work, but the good news is if you're in class and you're working on this, kind of looks like a brain. Okay, I get myself distracted. But if you're in class and you're working on this, we usually would spend like a whole period just on this one particular lesson. So, it's okay if it takes time in the beginning and all that. I realized I kind of sort of crossed that off. I didn't mean to do that. My apologies. But yeah, they definitely are a little bit similar throughout. So we'll do a few to make sure you're comfortable and they get a little easier with time. If you have a different way you like to write your problem out, please feel free. You don't have to use my little chart organizing device, but it does help me personally. If you look through on number 3, you might notice that one of these is already as broken down as it's going to get. Because one of these does not have a GCF and it doesn't have a squared. So the one that kind of stands out for me is towards the top. So sometimes when it's already factored, I like to put it like, or not even factored. If it's just a simple expression, I'll put like a little check mark by it, just so I know it. I don't have to deal with that one. Some people will factor the ones that look a little easier first. So like this bottom one, since it's a greatest common factor of 6, they might want to get that one out of the way. So we can put our 6 on the outside, and these cancel, leaving us with the A, and 6 divided by 6, got to put that one down as a placeholder. Sometimes it feels better to put a check mark by it when you factored it. It just feels a little better. Makes me feel a little better about all this factoring. And then we would go ahead and work on factoring the top ones, or the top and the bottom one here. This one here, it does have 3 terms. So your mind might go to big X, like big X, let's do it. But there's a 2 in front. So, big X doesn't always work out so friendly with the number in front. So let's break that down, divide by 2 first. I'm probably going to run out of a little space, but we'll make it work best we can. So we got a squared. Zoom it in just for the purpose of this video. And then we got a 1a or just an a. I find that when we factor, putting that invisible 1 does help people. And then 4 divided by 2 or -4 divided by -2 is that -2. This big X might be a little tricky, but try your best not to overthink it. I'm kind of the queen of overthinking stuff, but with math, not as much. So we got our -2 is what we're looking for to multiply to, and adding to -1. We only have 2 numbers to multiply to 2. 2 and 1. So we just have to decide what the signs have to be in order to add to -1. So we could try that out in our calculator. So I have students that struggle with integers sometimes. So I like to tell them, go ahead and try it out with 2 minus 1. And if that is not the bottom, then try it out the other way with 1 take away 2. And you'll see that you have your -1. So this 2 has to be negative. So it's going to be a take away 2. And then a plus 1. And we had a greatest common factor in the very beginning. We don't want to forget to put that out front. So we put that little 2 up there. And we are almost done factoring this beast. This is a beast of a problem, I would call it. Are you able to see that okay? Because I wrote really small on there. Okay, cool. Hopefully my at-home people can see it. It looks like it's zoomed in enough for me. This one over here, usually we do try the smaller number, but if we try 28 divided by 12, I get a decimal. So I want to try something different. Are there any other numbers that go into 28 and 12 that we could try? Maybe like a 4. I think a 4 would work. 4 would work. Is there any variables that they share? Good. So since they both have at least 2 A's, we can do A2. Perfect. Put that GCF on the outside. 28 divided by 4 is 7. And then stacked, we're going to subtract. And 12 divided by 4 with the negative. And these will cancel, so I didn't need to leave that much space, but that's all right. So we're just going to look and see if anything cancels across the top or the bottom.
7a minus 3.
Beautiful. I was really hoping we'd get to cancel that one out. Perfect. And then on this left side, it looks like we also have a plus 1, so we could cross those out. That part's kind of fun. And I don't see a whole lot else that cancels, so I'm really glad we did this one. So we only have 2 things left on the top. So we have the 2. Sometimes my paper get a little messy, so I'm the right answer over here. We have a 2 and an a minus 2 left on the top. Now on the bottom, you see how you have 2 things left over, and it's a 6 and a 4a2. Since this is a multiplication problem, if you have multiple terms left in the basement or even the numerator, you don't have to factor them like we did up here. You don't have to, FOIL them out and all that, but you can go ahead and multiply those together. If you left your answer like this and you're like, okay, Miss Amanda, I did all the hard work. I did the factoring. I did the canceling. Can't I just be done? Technically, yeah, I would take that. But just knowing if you go to take a standardized test or an Ivy Tech, a placement test, they may have you go ahead and multiply the 6 and the 4 together. This is where Miss Amanda always runs out of space. That's okay. I'm going to go into number 4 a little So you could multiply those together and it would look something like this. And for me, that is a-okay if you wanted to stop there. Ivy Tech does reduce occasionally, so I like to let people know, since I have some people that are aiming for college, is 2 and 24 could reduce since they're both coefficients and outsiders, since there's no parenthesis down here. So you may see this answer written as a minus 2 with or without parentheses. And then if we divide 24 by 2, we get 12. So either of those answers may pop up if you were to take a placement exam. So I have to let people know that. For the most part, they're all really pretty similar. There's a lot of big X on here. There's some GCF. Is there any, oh, snap, I need to talk about the division. If any of my fine in-person students need to head out, I respect that, but I can show you the first step on our division if you would like. So when you have a division problem, I'll go ahead and show you at least how to start out. Let's do number 7 here. What you do, and this is like regular fractions, when you first saw them, I learned this from I think my 4th or 5th grade teacher, something called keep, change, flip. So KCF kind of looks like KFC, but not 100%. So what you do is you change the division to a multiplication and you flip flop the numerator and the denominator on the second one. And then it just becomes the same problem like you had before. So you have your little second fraction switching around on you. And after you switch it, if you're the type of student that if it's like too much on the paper, you can always just kind of like scribble that out. And then you can go right to your big old factoring chart. Yeah. So it is very similar to the other ones. For those of you who want to stick around to finish this last one, I'll finish it out for our video folks at home. I'm getting tongue twisted, but just want to say thanks to my in-person people for joining me today. Wonderful work. This top one over here, since it has 3 terms, you can do your big X. So we'll put our negative 40 on the top and our 6 on the bottom. This one might be a little tricky to find your numbers. So you can take out your calculator and you can do 40 divided by, zoom that out, 40 divided by 2. Those 2 numbers are not going to add or subtract to 6. So we can try 40 divided by 4. And since I know 10 and 6, or 10 and 4 subtract to 6, I can pick 10 and 4 as my numbers. I have to find out what the signs have to be though. So since they multiply to a negative, one has to be negative and one has to be positive. So if I do 10 minus 4, I will actually get 6. But if that didn't work out, I could try 4 minus 10. So this factored problem would be n plus 10 and n minus 4. And if you needed the original problem written down, let me go ahead and put that on there for you. Once it's factored, you can put a check mark by it so you know what you're working with. This is our new numerator on the right, 3n plus 6. So we're going to drop that down. Since it's only 2 terms, we're going to look for a greatest common factor first, which they're both divisible by 3. Those cancel, leaving you with an n. And 6 divided by 3 is 2. And then since my GCF was 3, I have to put that GCF out front. I have this down here, which goes on the bottom here. And the last expression that needs to be factored is n squared plus 13n plus 30. You have 1, 2, 3 terms. So you're going to go right to your big X. and you're gonna find numbers that multiply to 30 and add or subtract to 13. So in our calculator, we can do 30 divided by 2. And we actually see two numbers that actually do subtract to 13, but one of them would need to be negative. And so the reason I know this is not the answer is if one of them was negative, I would get a negative 30, even if I had it the other way. So this one was a good one to do. So I need to try a different number, knowing that this is positive on top. They either both need to be positive or both negative. So let's try 30 divided by 3. 3 and 10, if they were both positive, would multiply to 30, and they would also add to 13. So that is why 3 and 10 are going to be my factors. So I'll put an n in each parenthesis. N times n is n squared. And a 3 and a 10, since those will now get me my 30 and my 13. You can always check that by foiling. So when we look through, we have a check mark. I forgot to put that over here. We have a check mark by all our final answers. So we're going to see if anything cancels out or looks like each other. Anything on the top can cancel with anything on the bottom. So this n plus 10 can cancel with this n plus 10 because they're the same, even if they're across from each other. And then we're left with this on the top. Oh, I see one more thing that can cancel, our 3 and our 3. So whatever's left over on the top, and it may even help if you highlight it. Whatever's left over on the top, you're going to put it together on the top of your final answer, and whatever's left over on the bottom, you're going to put it on the bottom. So our final answer for number 7, I'm just going to write it over here on this note. N minus 4, n plus 2 are my leftovers, and n plus 3. And that is my final answer. So just remembering with division that you do need to change this sign to a multiplication and then flip this second fraction around. I hope multiplying and dividing rational expressions made sense to you today, but if you do have additional questions, feel free to let me know and I can go over them in class, or you can shoot me a text and we will get it worked out. Have a great rest of your day.